we go. I think that worked. Let's go C. Okay. I would ask what problems did we do, but we didn't do. Right? Am I wrong? Nobody's going to fight me. All right. So we got some math to learn. Sound good? Yes. Yes, yes, yes. And do some problems. I'm going to give you some homework, and then I'm going to let you go so you can do the homework and study for your test. Sound decent and reasonable? Okay. You know, looking at this book. Good morning, Gavin. Looking at this book. Let me double check. You know, it's funny a little bit. It's almost like we've gone backwards. It makes sense, I get it, because geometry, pictures, right? But in Algebra 1, we learned this topic. This is a repeat topic. In Algebra 1, we learned this topic, and we learned all these little formulas for it. It's this, and you switch the x's and the y's, or you make the y's negative, or whatever, and this is this. But this is like, just look at it, which is funny, because a lot of geometry is, you can't just look at it. You have to be able to prove it. But in this one lesson, it's a just look at it. So this is uber easy. This is vocabulary. So the lesson, this is 4-7, is called congruence transformations. Okay. So what does congruent mean? It means what? Oh, you can go blow your nose. Am I out of Kleenexes in here? Yes, pretty much. What does congruent mean? Equal. Not just equal, but the same size and shape, right? All things equal, right? Congruent and equal are almost the same, right? Same size, same shape. Right, and then they're congruent. So a congruence transformation will be a transformation where it stays the same shape. So the one type of translation we are not talking about is we're not talking about a dilation. We're not talking about that. What is a dilation? Dilation is where it gets bigger or smaller. Right? So that's the only one that we're not talking about. We're talking about, we're not talking about something getting bigger or smaller. When we go later, I think it's chapter 7, but I could be lying. When we go later in the book and we get to similarity, then we talk about similarity transformations, and then we'll be talking about dilations. But this one, we just are moving, reflecting, and rotating. Except we have to. It's math, so we have to use fancy vocabulary words for some of those, right? So, if we have a shape and we just move it, fancy word for that is safe. Hello. Welcome to geometry. Glad you're here. If we just move it, so if we take like this triangle, I'm going to try to draw the, just move it and not rotate it. We'll see. Do the best I can. Isn't that a cute squiggly line at the bottom? We love it. Love to see it. If I hadn't accidentally broke my other triangle, we could have done it with that one. If we just move it, we move all the vertices over. That's called a, oh look, I made a prism on accident. Should have done different colors. If we just move it, that is called a translation. Easy money. You probably learned this in Algebra 1. If you were in my Algebra 1 class, you did learn it in Algebra 1. Now you may not remember. That's totally different. All right, it's called a translation if it just moves. You finished geometry last year. Well, that's great. Are you in junior high, high school, college? What are you? All right, that's called a translation. Now, we can also do something else. We can take and we can flip it, right? We can take our triangle, all right? And we can flip it. We can flip. Now, when we do a flip it, it's got a name, which we'll give it its real name in a minute. When we take it and we flip it, we flip it over something. Often we'll flip it over the y-axis or over the x-axis, but you don't have to make it one of these. And if we take it and we flip it over this axis, so this is flipped over this axis. So this flipped over, right? So this one is this one, and this one is this one, and this one is this one, right? Of course, that symbol makes it look like I'm doing the next one, so that's probably a bad idea. It's hard to really illustrate this one with like scribbles, right? All right, but what we're doing is we are reflecting it, which you probably could have pulled that word. This is a reflection, all right? Tenth grade, awesome. Let's see, geometry in 10th grade, in 9th grade, that makes sense. Makes sense. Reflecting it over, right? Easy peasy. That's a reflection. There's one more kind of congruence transformation, a transformation where it stays congruent, stays the same size and shape, but moves. What is the one that we're missing? Anybody know? No, we already did that one. It would be like a rotation. Wow, y'all can read. It's amazing. Right? So you can rotate it. Now, the tricky thing about rotation, and when you go to do the, excuse me, you may see some of the ways that these are tricky. Some of them may look like one thing, but really are something else. Because usually we rotate around some point. And if it's a point here, then it's just, and that's obviously a rotation, right? That's easy money. But if it's a point over here, and it goes, that can look like some sort of translation or reflection or whatever. But it's still a rotation if it rotates around some other fixed point, right? So it's something where we're rotating around. Spinning around some fixed point. All right, so this is a rotation. Right? Easy peasy. So if you look at your book on page 297, 1A, what is that? Is it? Look again. It's a reflection. It's a reflection over, oh, you're looking at the example 1A. I'm sorry. I wasn't clear. Sorry. That's my fault. Guided practice 1A. Yes, example 1A is a rotation. The guided practice 1A is a reflection. It's a reflection over the x-axis, right? What would guided practice 1B be?
Translation.
Oh, look at it. Is it in the same orientation? It doesn't see how the little point goes kind of up on the first one and then it's over here on the next one? So translation is just moved, so it'd have to be in the same orientation, right? So that one's not a translation, so what is it?
Rotation.
It is a rotation. Looks like it's a rotation about the origin, which most of the ones in this book will be when it does a rotation. So it's a rotation about the origin. It took it and spun it around, right? That's why I was saying where the rotations can be a little bit tricky because it looks like it moved, and it did move, but it didn't move straight. It moved around, right? So you got to look to make sure it's faced, whether it's facing the same direction or in different directions. And so if we look at guided practice C, what is that one?
Translation.
That one's a translation, right? It's the same up and down shape, and it kind of goes whoop, right? It didn't spin, right? There we go. Okay, so let's do one with some points in it. We're going to do guided practice 3 at the bottom of page 298. So it says triangle JKL with vertices J, -2, 2, K, -8, 5, and L, -4, 6. Is a transformation, so this is the transformed one. So this is the second one, right? And then the original, so it is a transformation of triangle PQR with vertices at P, 2, -2, Q, 8, -5, and R, 4, -6. Graph the original and its image. Identify the transformation. So this is pretty straightforward. This is really kind of going back to like 4th, 5th grade math, essentially, just with a vocabulary word at the end, right? Just plotting points, connecting the dots, which we don't always do, and I don't know why I drew it crooked, just because I was talking, I guess. Let's try again. All right, so the original is at 2, -2, right? So X, 1, 2, and then down 1, 2. We put a dot. We'll go ahead and label that as P, easy peasy. And then Q is at 8, -5. So 1, 2, 3, 4, 5, 6, 7, 8. -1, 2, 3, 4, 5. So right here, Q. And then R is at 4, -6. 1, 2, 3, 4, -1, 2, 3, 4, 5, and 6. Okay, so there's the original. Connect our dots. Oh, it's a triangle. What was your first clue? 3 points. Good job. I don't know what's happening. It's okay. Don't worry about me. I'm probably sane, except for the fact I chose to be a math teacher. There's the original. Great. Now let's draw the transformation. -2, 2. Oh, that's looking promising. We're kind of like looking at these points and where they are, like, oh, I think I might know. What do we think it is without even drawing it on there? What does it look like it maybe is? Anybody have thoughts about it yet? I don't think it's a translation, but we'll see. I think it's something else. But let's draw it and see.
It's almost exactly the same, except the negative signs are switched.
Yeah, that's true. That's true. That's true. And if you remember back to our Algebra 1 instruction on this, you might be able to pull something from that, but we won't we won't stress. -2, 2. There's a J. All right. K is at -8. 2, 3, 4, 5, 6, 7, 8. 5. 1, 2, 3, 4, 5. So he's up here. I'm obviously not drawing my scale perfectly, but I think we'll be able to get what's going on. And then L is at negative 4, negative 1, 2, 3, 4, positive 6. This is L. And we connect the dots. So here's our question now. How was it transformed from this to this? What did happen? Is it in the same orientation? No, it's definitely not. So it's not just a translation, right? Now maybe it's two things, maybe, but it's definitely not just a translation, but is it a reflection? Could we take it and go, no. Okay, so hopefully it's a rotation. Let's take a look at it. If we take and we flip this around, and we take and flip this around and this around, does now it match? Yes. Yes, it does. This is a rotation. Obviously, if we use graph paper, it would look even better. My scale kind of shrunk on this one, which is why that one looks smaller. I didn't actually make a real congruence transformation, right? But if you were using graph paper, it would be much easier to see. This is a rotation. It is totally a scam. You're totally right. Bruh. So the instructions also ask you to verify that it is a congruence transformation. How could we verify that this is congruent to that? We have 3 ways to prove something congruent. Actually, we have 4. I don't know why I said 3. Because 3 sides, I guess. There are 4 ways to prove that triangles are congruent. What is the only one we could get to using math with this? Can we learn anything about the angles because of any formulas that we know at this point? It's a 50-50 odd of guessing wrong or right? Yes or no? Do we know any formula to figure out those angles? So we could, with slope formula, figure out whether lines are perpendicular or parallel. They better not be parallel, or we have some wonky A shape that can't exist. We can't have a triangle with parallel sides. That's not possible. But so hopefully they're not parallel. So we could use slope formula to do that, but that still doesn't tell us the angles. The answer is no. I know y'all are struggling. It's like there must be something, but the answer is no. We can't figure out the angles from what we have. Now later, when we learn some trigonometry, then we could get there, but we don't know nothing about the angles. Can we find the distance of all those lines? Yes. We have a formula for that. What's the formula called? Distance formula. Whoa. What is the distance formula? Do we remember it? D equals. Got it. Got you. And then what? What comes next? Anybody remember?
Is it time over speed or the other way around?
Okay, so yes, distance equals rate times time. That's not the distance formula we're going to use for coordinates, but that is absolutely a formula, and it is absolutely true. But we don't know anything about speed and time, so that's not the one, right? But no, that's true. You're not thinking of something that's wrong. D equals R times T is totally a formula. Yeah, the square root symbol. Yeah, the big old fat square root symbol. Now what goes in the square root symbol? Is it coming back to you? I'm giving you pieces. This is a formula that you need to memorize. Make you a flashcard. Read it every day. Just like take 2 minutes. I'm serious about that, by the way. Like if you will do that, like all the little formulas, like make you some flashcards, like take 5 minutes a day and you'll know them all. Like 5 total minutes, not 5 per flashcard, 5 minutes a day. If you'll do that, you'll know them all. Easy peasy. It's like the easiest thing in the world. Take 20 minutes to make the flashcards, 5 minutes a day. You can memorize them, no big deal. D equals the square root of the difference of the x's. So x2 minus x1. You could. It comes out the same in this formula, whether it's y2 minus y1 or x2 minus, and then x2 minus x. And it may be easier to memorize because like slope formula if you do the y's first. So if you want to memorize it that way, that's fine. It's same because of plus and squared. So that's fine. If you do y2 minus y1 plus x2 minus x1. Either way is fine. They both are the same mathematically, right? Because since it's a plus in the middle, we can switch that order and he don't matter. As long as it's the x's together and the y's together, right? So we can find, in order to prove that these were congruent, we go find all of those distances. If I chuck one of these on the test, I won't make you do this part because time, not because you can't. But I won't make you do that part because I want you to have enough time to do the proofs and all of those things. Yeah, this chapter is like all proofs, so the test is going to be like all proofs. Like expectation versus reality, there you go. Okay, so I think you have lots of time. Yes, I'm not wrong. So I'm going to assign you some homework for this lesson. Theoretically, the work is not that difficult. And so if you have any questions, if you stick around, whether you're in here or whether you go in another room to do it, I don't care. But if you want to work on these and work on this homework, if you have questions on it, you can ask them. And then you can start studying for your tests and all of those things. So I'm not just letting you go early. I'm letting you go with a plan. So your homework for this lesson is going to be pages 299 and 300. And we're going to do numbers 8 through 26 evens. All right, there you go. That ends the official portion of the class. If you want to stick around in here and work on your homework, you're welcome to. If you want to go in another room, you're also welcome to. If you want to leave, you're welcome to. You have a test on Tuesday, which probably means all the rest of my dates are wrong. That's